Welcome uh, to a discussion of the use of the simulator for the quantum computing class. This is using the simulator, the quantum simulator that's available from IBM, and this is just a very brief and very low-level elementary introduction to the use of the simulator. The first thing you need to do is to go to Quantum Experience and get an account. And then once you get your account, you can log in. Now the link that I have here, as you can see, is https://quantumexperience.ng.bluemix.net. And when I went to that link and then logged in, typed in my username and password, then I was taken to this page. And I want to point out that on this page over here, on the right, there are these quick links. There's frequently asked questions, a beginner's guide, and a full user guide. And if you look at these, for instance, let's just look at the full user guide. You will see a number of links here that you can access, discussing all kinds of different topics related to quantum computing. And you will notice some familiar topics over here, the qubit, superpositions, the block sphere, multiple qubits, entanglement, the Deutsch-Jozsa algorithm. So there's quite a bit that we've covered in the class that is also covered in this user's guide, but there's also a great deal more. So for those who are interested in learning more about this topic, I would very strongly suggest referring to this user's guide. To be honest, probably it would be possible to cover this whole course or to design the entire course around this user guide alone. But the purpose of this talk, though, is to just give you a brief introduction to the simulator. So to get there, one way you can get to the simulator is go up here to Community, and I think it's Learn. Yes, go up to Learn, and then under the Learn tag, you see the different links that you can choose. What is quantum computing at IBM, videos, beginner's guide, full user guide, QIS, KIT tutorials, and then Composer. And Composer is what we want to choose. So I'll come down here and choose Composer. Now, once you've chosen Composer, let's see this. Okay, there we go. Now, we get to the quantum simulator here, and this is what we want to concentrate on. Now, the reason that they call this Composer is that this is like a musical score. Here you can see down below that they call them quantum scores. And the idea here, notice that over here on the left, we have Q0, Q1, Q2, Q3, and Q4. So this is a 5-qubit machine. And actually, we have access to the computer is to a 5-qubit quantum computer. If you after you put your gates here on this score, if you hit run, you will actually be using a quantum computer. But some of the disadvantages of using a quantum computer are that you might have a significant delay before you get your results, and also you will use up some of your account. When you sign up to get this account with IBM, you're given a certain amount of time on the quantum computer, and every time you use it, you will deplete a little bit of that time. So I would definitely recommend, until you have a good bit more experience, that you not use the computer. Instead, you use the simulator, which will give you immediate results and also is completely free. You can use the simulator as much as you wish. So to begin to get a flavor for how this goes, we see here some familiar gates that are listed. And so let's choose, for instance, X. I'm going to choose X, and I'm going to put it over here on the Q0. And now to see what happens, I need to measure the qubits. And so I'll maybe measure the Q0, and I'll measure, you can't put another one right under that one, so we put maybe measure Q1 here. And now we don't need to measure anymore. If you want to just, for right now, assume that we're interested only in the first, only in these two qubits, Q1 and Q0, that would be fine. So let's see what happens if we do this. I'll go ahead and simulate this and say okay. Okay, and now what happens? Okay, well, down here below, it tells us that all of the results. Now, this is a frequency right here. On the left-hand axis is frequency, and all of the results with a frequency of 1, we have arrived at the result 00001. Now, this makes perfectly good sense. If we go back to the code, remember that what we did was we had the X gate on this, where the qubits go from bottom to the top. So the last one is Q0, and all of these qubits are initially equal to 0. Now you can see that right here. So they're all initially equal to 0, but then we flip Q0, and so that's why all of them will still remain at 0, but Q0 and Q0 is flipped to 1. Now, let's see what happens if we put a Hadamard gate here, let's say for Q1. Now, we know that the Hadamard gate should make Q1 flip from 0 to 1 over square root of 2, 0 plus 1 over square root of 2, 1. So let's simulate this and see how that will work. So we simulate it. And sure enough, we see now that now instead of getting all of our results in one state, our results will be in two states. And notice that in the first state here, we have 00001, and in the second one, we have 00011. So this makes perfectly good sense that that last qubit on the right, which is Q0, is still being flipped from 0 to 1 for sure. The first three qubits are for sure 0. But the second qubit from the right, which is Q1, half the time it's equal to 0, and half the time it's equal to 1. And that's because of the Hadamard gate. Now, just to further emphasize how this works, If we put in another X gate here on Q0, that should flip it back to 0. So let's check and see if that is indeed what happens. We'll simulate this. And notice now, indeed, the Q0, which is the last qubit on the right, has been flipped to 0. It's 0 in this state, and it is also 0 in this state. But Q1 has turned out to be, it as before, sometimes it's equal to 0, sometimes it's equal to 1. Now in this case, it turned out not to be a 50-50 distribution. It turned out to be 57% and 43%. And if we do this again, okay, 52% and 48%. So this may not turn out to be exactly 50% and 50%. You should be aware that these are probabilities and not certainties. And so this in both the simulator and in the computer, you don't get certain results. So be aware of that. Now, if we put a Hadamard gate on the Q0 as well as Q1, now we should have the possibility of getting either 0 or 1 for both Q0 and Q1. And so now we should be getting 4 roughly equally likely results, with 0 in the first 3 qubits and either 0 or 1 in the last 2 qubits. So let's simulate and see if that is indeed what happens. And there we do indeed have it, and we see that the likelihoods, theoretically we would expect 25% for each one. These two end up to be close to that. This one's 21% and this one is 33%. But notice that they are exactly the outcomes that we had predicted. In each case, the first 3 qubits are 0, and then for the last 2 qubits, they can be either 0 or 1. And so you can, as I mentioned already, we have other gates that we have looked at before. We have the X, Y, and Z gates. We have the Hadamard gate. And let's see here. I believe I've noticed before that there is a C0 gate. Let's see what happens here. You can see there are a number of possibilities. I have seen on here before a controlled NOT gate, but I'm not seeing it at the present time. There are, you can see when you click advanced, you get more advanced gates, And I don't doubt at all that we could implement the controlled knot, but I believe that in the past there has been one actually available, readily made. But the point is that you see that you have a number of possibilities to play with this and to get a little more experience, a little hands-on experience with some of the topics we've been discussing in this course. And then, as I said, once again, if you look at the user's guide, there's a lot of extra material available. And one final thing I want to point out here is when you look up on the score at the top here, it lists up your units. And this is what I was referring to earlier. If you use the simulator, you don't use any of the units. But if you use the quantum computer, you will exhaust some of these units. So that's a brief introduction to how the simulator works. And I encourage you to take a look at that. I think that you might find it enjoyable, and I think also that it could help to possibly reinforce some of the ideas from the course. So that's it. Thanks.